Hey guys, welcome back to Code Streak Daily. In today's video, we are going to solve the problem of daily streak of Leetcode. We have the title count square submatrices with all ones. So it's a medium level difficulty problem. Given a m cross n matrix of ones and zeros, written how many square submatrices have all ones. So here we have the matrix. It's a 3 cross 4 matrix 0 1 1 1 1 1 1 1 0 1 1 1. The output is 15. Okay, there are 10 squares of side 1, maybe 1 2 3 4 5 6 7 8 9 10. There are 4 squares of side 2, like you see 1 1 1 2 3 and 4. There is 1 square of side 3, this whole matrix. So therefore the number of squares will be 10 plus 4 plus 1 equals to 15. Okay, we have another matrix 101 110 and 110. uh, there is one square of side 2. Yes, you see here we have 2 cross 2 and there are 6 squares of side 1. 1 2 3 4 5 6. So therefore total number of squares are 6 plus 1 equals to 7. Okay, here we are going to use the dynamic programming skills, counting the number of square submatrices in a 2D grid where each square is made up of only one. Okay, this kind of problems frequently appear in coding interviews and is a great way to test our understanding of matrix operations and dynamic program. Let's dive right into the problem. Okay, so the problem looks complex at first, but we can solve it efficiently using the dynamic programming approach. Don't worry about that. So the approach we are going to use leverages a technique called the dynamic programming. We'll create a dynamic programming matrix where each cell dpij stores the size of the largest square submatrix that can end at that specific cell. Next, we are going to determine base cases. Cells in the first row or first column can only form 1 cross 1 squares if they contain a 1. So, we'll initialize them to either 0 or 1 based on the values in the input matrix. Okay, so here we'll use a dynamic programming formula. I'll write the formula first here. So, here dp of ij will be equals to minimum of dp I minus 1 and j. Next, dp of I and j minus 1. Next, dp of I minus 1 and j minus 1 plus 1. So we're going to use this formula, and each value in dp of ij represents the count of squares with ij as the bottom right corner. So summing up all the values in dp gives us the total count of squares. Now let's implement this using our code. Let me reset the code here. So here we have a class solution defined, and we have a function called count squares where matrix is passed and we are gonna return an integer. Okay, before that I'm gonna import from typing import. I'm gonna import the list. Next, then I'm gonna check if the matrix is empty or like having no rows. In that case I'm gonna return 0 for that. Okay, like if not matrix or not matrix of 0, in this case what I'm gonna return just 0. Otherwise what I'm doing, I'm taking two variables m and n where I'm initializing them with length of matrix and length of matrix 0. So in this way we will get the length of matrix and length of matrix 0. How many columns are there? Okay, next we also initialize a variable called total squares to 0 to store our final answer. Okay, total scores equals to, sorry, total squares it should be total squares equal to 0, and we have to initialize our dynamic programming array, right? dp equals to 0, how many times? N times for underscore in range of m. So these many columns and these many rows. Okay, next, now we have our main logic. Here we will be use a nested loop to iterate through each cell I and j in the matrix. Okay, I'm taking a for loop here for I in range of m and for j in range of n. In this case, what we are checking, if matrix of ij is equals to 1, in that case we also have to check if I equal to 0 or j equals to 0. What we are going to do, dp of ij equals to 1. If not, dp of ij equals to the formula which I have told you, right? Minimum of dp I minus 1 and j, dp I and j minus 1, dp I minus 1 and j minus 1 plus 1. Okay, next what you are going to do, total squares plus equals to dp ij. Okay, I'll tell you here. First of all, we are checking if matrix ij is 0, then we skip this cell because it can't form a square of ones. Next, if matrix ij equals to 1, we check I or j is 0, meaning it's in the first row or column. If so, we set dp ij to 1 because any 1 in the first row or column can make form only 1 cross 1 matrix. Next, if we are not in the first row or first column, we calculate dp ij using this formula. Okay, this formula. Finally, we add the value of dp ij to squares. dp ij to squares because it represents the count of squares with ij as the bottom right corner. Okay, what we have to do next? We just have to return total squares. Now let's run the code and check. Okay, we have a runtime of 0 milliseconds and both the test cases are passed. Now let me submit the code and check. Yeah, as you can see here, our code beats 95.65% of users and we have a runtime of 50 milliseconds in total. Okay, so, and I hope this explanation is helpful for you. Let's discuss about the time complexity also. The time complexity for this solution is order of m cross n, where m and n are the dimensions of the matrix, and the space complexity is also order of m cross n due to the db matrix. Okay, and by using dynamic program approach, we solve a complex matrix problem with an efficient and simple solution. If you found this video helpful, be sure to hit the like button and subscribe to CodeStreak Daily for more programming tutorials. And if you have any questions or suggestions, please do put that in the comments of this video. And if you have any other approach, please do put that approach in the comments of this video. I'll surely check on that. See you in the next video, guys. Until then, keep streaking.